circle, and we have a sector, and we have the central angle, and we want the radius. We need either the area or the length of the arc. So in this case, we are given the area that's 32 pi units squared. We're given the central angle, so of course we're looking for the radius. We can be given the radius and look for the central angle. It's just all whatever they give us. We have to be given at least 2 of the 3 of these things. So we're going to put it into our area formula. A is 32 pi. And then our theta is 45. That's our central arc. Here's our portion of the circle fraction. And we don't know what our radius is. So now we have to undo the right side to be able to solve for r. So I'm going to keep this right here stuck together as long as I can. Whatever's with the whatever I'm trying to solve for, I'm going to keep it together until the last minute. So now this part right here is multiplying to whatever is with r. So the opposite of multiplying is dividing. So if I divide it on both sides, of course 45 over 360 would cancel out on the right side. But when I divide fractions, I keep, change, flip. I don't really divide them. Okay? So now if I were to multiply this and then divide by this, I end up getting 256. Don't forget your pi there. And so now I can take apart that whatever's with r. Okay, so pi is multiplying to r. So I'm going to divide it onto the other side. So pi divided by pi is just 1. Don't have to put it. So now I have 256 times r squared. And I just want r. So I'm going to undo the square, which means I'm going to square root it. And at the square root of 256 is 16. So my radius is 16. Okay, now we're going to do something where we don't have our theta. We don't have our central angle, but we have the radius and we have the length. We could be given the area, we could be given the length of the arc. As long as we have 2 of those things out of the 3, length or arc is 1, the radius, and then your central angle. We can do this. You have to remember that the length of the arc is theta over 360 times your circumference of the circle. So now I'm going to plug in what I have. Remember, the length of the arc is not the measurement of the arc. It's measured in different units. So the length is 4 pi. My theta, I don't know, so I'm going to leave that there. And we have 2 times r. 2 times 16 is 32. And now we're going to solve for theta. In the area one, we had the whole fraction, so we took that over first. But in this one, what we're solving for is part of that fraction. So I'm going to keep that fraction together as long as I can until the last minute. So I'm going to take this part. It's multiplied towards the thing that has theta in it. So I'm going to divide it over here. Okay, at this point, my pi's cancel out. I'm just going to keep my numbers. I don't even need to reduce yet. And I have this. I'm trying to find theta. So right here, these are dividing. So I'm going to multiply. This is 360 equals theta. So now you're going to go 4 times 360 divided by 32. And you end up with 45 degrees. So the measure of the central angle is 45 degrees. And then I said, hey, what's the measure of the arc? Measure of the arc is the same as the measure of the central angle, but the length of the arc is 4 pi. So now you've learned how to solve for radius or theta. You can solve for theta in an area problem. You can solve for radius in a length of the arc problem.